Sanibonani. Hellos everyone. Namhlanje ke ilelo suku lelo elokuthi ngenzele ama-Newton's laws, okay? Masiqale ngama-Newton's laws, ngingathanda ukuthi siqale sikhulume ama-types of forces. Ama-types of forces, we have normal force, force of gravity, force applied or applied force, frictional force, tensional force. Ukuze si-understande kahle nama-forces lawo, nama-types of forces. Si-understand masiwabona ku-force diagram. Force diagram. So i-force diagram really guys, i-diagram ekhombisa i-object. Makuthi i-object yi-box, uyayibona i-box and nama-forces pointing away from the box. Uyayibona leyo? Force, this is a normal force pointing away from the box. This is a force of gravity pointing away from the box. Force applied pointing away from the box. Friction pointing away from the box. So we can say that normally a force diagram is characterized by you seeing what type of object it is. If it's a box, you see a box. If it's a car, you see the car. And the forces coming out of the object. But if we are talking about free body diagram, any object is represented by the dot. For example, now whatever object it is now is represented by the dot. This box right now is now represented by the dot. And the normal force now is moving away from the dot. You see? You can write F subscript capital letter N or capital letter N, normal force. And then the force applied will be in this direction here. And the friction pointing on the other direction. And then force of gravity pointing downwards. Or this you can simply say this is weight W. Alright, previously in the video benefit introduction, on that video I explained clearly that you must know the definitions of these types of forces. For example, the question would say define the normal force. Looking at this force diagram or this free body diagram, if I say this is the ground or this is the what? Surface. You will see now that force, normal force, when you define it, you would say it is a force or component of a force. Why I'm saying or component of a force? Because sometimes an object will be on the inclined now. You see? The force now will be on the inclined. Find that there is going to be, let's say, the what you call, the force applied is applied at an angle. That means we have to resolve that force applied into x and fay and y and x. So this Fg, if you can look at this now, you will find that normal force plus Fay equals to Fg. Then you will find that now Fn will be Fg minus Fay. Why I'm doing this? I'm doing this because the definition says it is a force or component of a force. Why I'm saying now component? Because this part here, this is the component. Y component. If you can see now, the normal force is equal to Fg plus the Fay component. You see? Alright, let's come back to the definition. I was saying normal force is a force or component of a force that the surface exerts on an object in contact with it. You see? And it acts perpendicular. Normal force acts perpendicular to the surface. Guys, that's very important. All the time, normal force acts perpendicular to the surface. That's very important. Let's repeat. Normal force is a force or component of a force that the surface exerts on an object in contact with it, and it acts perpendicular to the surface. So when you say perpendicular, it means now it forms an angle of 90 degrees all the time. Whether the surface is horizontal or the surface is inclined, you must know that normal force acts perpendicularly to the surface all the time. That's very important, guys. Then, force of gravity. You must know that force of gravity, it is a force that the earth exerts on an object that is on or near the earth's surface. I get that, I think. Sometimes the object, let's say this is the earth. If the object is here, that means the object now is on the earth surface. You see that object now, this is earth. If the object now is above the ground, that means that object now is near earth surface. So the object on the surface of the earth or the object near, because some of the objects are flying, the helicopters are flying, some objects are falling free. So if it's up there, it's gonna come down, because why? The earth always pulls objects with a force towards its center. Alright, so force of gravity is just the force on an object that the earth exerts on it, near or on the surface of the earth. Then, frictional force. Frictional force is a force that opposes the motion of an object parallel to the surface. If the object is moving this direction, the frictional force will oppose that motion of an object in the other direction. So, in other words, frictional force always opposes the motion of an object. So, frictional force can be kinetic friction, can be static friction. Kinetic means moving object. Static, object that is not moving. So, yes. So, about the definition, guys, I'm just explaining now. I'll just give you the definitions. Alright. You must also be able to detect or see the difference between force diagram and figure diagram, as I explained. Alright. Now, I think we must go to the Newton's laws now. First, Newton's first law of motion. Remember, also I will give you the definitions according to examination guidelines, guys. Please take the definitions according to examination guidelines. Okay, let's look at this one now. Newton's first law. Remember, this is the law. This is the law. Many years ago, Newton, Sir Isaac is the one who came up with these laws. So, a scientist, he was very gifted. There are many more scientists who proven his laws to be true. So I love the way scientists act. If omunye waqhamuka ngomnyaka ukuthi omunye qhubeke nale study sizenalo up until that's why it's physics and science, and it's all about facts. It's proven. So ingakho ngithi guys, this is a law. This is a law. You have to memorize it. Okay, let's try to see what it says. So this law states that a body will remain in its state of rest or continue usho guys, Newton's first law of motion. A body will remain in its state of rest or continue to move at a constant velocity unless a non-zero net force acts on it. Okay, come again. Usho ukuthi object mangabe imile izohlala imile. Mawukuthi object iyahamba, izoqhubeka ihamba, uyayibona leyo nto, until there bekhona i-force actayo on it, whether mayihamba to stop it or mayimile unless the force acts on it i-cause ukuthi ihambe. Ngicabanga ukuthi leyo nto uyenza sense. Ngimile lapho la usho kanjani umthetho. Okay, that's Newton's first law. Very important, guys. This will be, you don't know whether, I meant to say this will be examined. Maybe they will say state Newton's first law of motion. You must state it. All right. So let's go to Newton's second law of motion. Newton's second law of motion. Newton's second law of motion. Taking imagine Newton's second law. States that when a net force acts on an object the object will accelerate in the direction of the net force. I'll say at an acceleration that is directly proportional to the net force, and inversely proportional to the mass of an object. Okay? This is a very good law again by Sir Isaac. So, when a net force acts on an object, the object will accelerate in the direction of the net force. That's the first part that must appear on your part of your definition. And the second part must indicate that this acceleration is directly proportional to the net force and inversely proportional to the mass of an object. We can write this in a mathematical expression. Newton's second law, we say net force is directly proportional to the acceleration. Secondly, acceleration is inversely proportional to the mass of an object. Yes. Okay, this guy, if this guy pushes this box, I like to explain what is a net force. Because this right here, we don't see it there, but we see it when we calculate. So I can say net force. Let me explain first what net force is. Net force is, in other words, net force is equal to sum of all forces acting on an object in the direction of the motion. Okay, I think this definition is wrong. Let me just say, net force is just the sum of all forces acting on an object. Okay? So, why am I making this on Tanzania? Because look at this first diagram here. This guy is applying this force this direction. Let's say the surface is rough. Therefore, if the surface is rough, the friction will be in the opposite direction. Alright? Okay. According to this scenario I made here, we know here there is a normal force. We know here there is a force of gravity. But now the object does not move up and down when you push it this direction. When you push it this direction, it's not moving up and down. It moves that direction. But we do have an understanding that there is a force applied by the surface on this object. So normal force and then weight down. So normal force is equal to Fg according to this. Then there we go. So according to this diagram, I would say net force is equal to force applied plus friction. Remember, force generally is a vector quantity. So I do believe that all of you knows what a vector quantity is. So just for those who forgot, vector quantity refers to a quantity, a physical quantity with both magnitude and direction. Let's say this force now is 20 newtons. That's the magnitude, 20 newtons. But in terms of the direction, this is east, west, north, and south. So this thing, if this object is moving towards east in an easterly direction or towards the right, okay? So my right there means direction. My 20 newtons there means magnitude, the size. So that means on the calculation now, that direction, I must say maybe towards the right, it's plus. Towards the left, it's negative. Up, it's positive. Down, it's negative. Why I'm putting plus, minus now? I'm simply in a calculation representing what? The direction. So this one is positive, this one will be negative. So whatever answer, whether the answer is negative or positive, if the answer is negative, that negative number represents what? The direction. Or that positive answer represents what? The direction. Okay now guys? So I'm talking about net force so that you understand. So here we are talking about the net force. This object will accelerate in the direction of the net force, because we can find the net force now here. In other words, what we do on the object, we apply the force. Okay? In other words, the net force now, it can be in the direction of the force applied, the net force. So let's say this is 20, this is what? 5 newtons, this friction strength, you see that. If I substitute here, I'll find that this is plus 20 plus minus 5. You see now, this is going to plus 15 newtons. I can just leave this because this sign, plus sign, is telling me the direction there. Or I would say 15 newtons to the right, to the right. You see, the net force is 15 newtons to the right. The force applied was 20, and the net force is in the direction of the force applied. The net force. Like this. So let's come back here. So I was trying to explain this concept of net force. You must know that to get the net force, you sum up all the forces that act on an object to get the net force. So task now we're going to say, let's change this now into a formula first of all. So the formula under Newton's second law is going to be net force equals to ma. Okay? You know, according to that example, net force is going to be force applied plus minus friction equals to mass times acceleration there. As been the 40 Newton's second law. Newton's second law states that when a net force acts on an object, the object will accelerate in the direction of the net force at an acceleration that is directly proportional to the net force and inversely proportional to the mass of an object. In other words, the acceleration might increase and net force here increase. But mass of an object increases, acceleration decreases. Mass decreases, acceleration increases. Yes, so in other words, we'll apply my object to apply force object here direction, object is to accelerator with the direction or apply upon the force, and the acceleration to the direction of the net force. Yeah. Let's stop. Actually, it's about this law, Newton's second law. Count now, you get the term, Newton's second law. That's it. Then we mathematical expression, Newton's second law, net force is directly proportional to the acceleration, and acceleration is inversely proportional to the mass of an object. So this formula is very important when you solve the problems on Newton's second law. All right. Okay. Newton's second law. I hope we are together. Now let's move on to Newton's third law of motion. Now we are going to see what does Newton's third law state. Okay. Here, Newton's third law states that when one body exerts a force on the second body, the second body will exert a force of equal magnitude on the first body but in opposite direction. I don't know if I exert a force on this whiteboard will exert back to me the same or equal amount I exerted on it. I exert it maybe towards the right, and then this one will exert to me towards the left. That's it. Action and reaction. I put a force, then I put an act, I'm acting. This one, whiteboard, reacts. So, yeah. We will just say, now if FA, force A exerts on force B will exert the same magnitude of the force but in opposite direction, because this one is positive, this one is negative. Therefore, if now I say FA plus FB, that means the resultant force there is going to be 0. Okay? Alright. That's Newton's third law of motion. That's a law. Memorize it. Let's repeat it. So, that's what it says. When one body exerts a force on the second body, the second body will exert the force of equal magnitude on the first body, but in opposite direction. That's it. Newton's third law. Memorize that. Keep it to your mind, and keep it that way. Let's move on to the next law. This one is This one is Newton's law of universal gravitation. Newton's law of universal gravitation. So what does it say? Or what does it state? So this law states that say this word now, universal. This now is universal. It doesn't have to do with planet Earth only, with other objects, universal. Okay, so it says that now every body in the universe attracts everybody in the universe attracts every other body. With the force that is directly proportional to the product. Everybody in the universe attracts every other body with the force that is directly proportional to the product of the magnitude of their masses and inversely proportional to the square of the distance between their centers. Huh? This, guys, is Newton's law of universal gravitation. So this law states that some people say other definition, every particle in the universe attract other particles with them, but I'm saying everybody in the universe attracts every other bodies with the force that is directly proportional to the product of the magnitude of their masses and inversely proportional to the square of the distance between them. Okay? Oh, here again, I think we have the mathematical expression. Let's look at the mathematical expression here. I think that's the spelling of expression, like Newton's third law. Newton's universal, whatever. So the first bullet now I would say, okay, to my understanding, this force, I think it refers to force of gravity, gravitational force. So I would say Fg is directly proportional to mass 1 times mass 2. This gravitational force is directly proportional to the product of the magnitude of the masses of their own bodies. And number 2, this gravitational force is inversely proportional to the square of the distance. That's it. And I can just fast forward this saying, the formula here is going to be F, B, G, and then M and M1 and then M2 all over R squared. This is the formula that you must know. And then there is a constant here. I think this G is equal to 6,67 times 10 to the power minus 11. Newton's watt, but I'm not sure about these units here. But these units represent all the units involved here. Like newtons, kilograms, squared, meter, squared. I don't know which one is sure, which one is negative, which one is positive. But look at this on the formula sheet. This don't worry about the value memorizing because you do have data sheet. And then you can just see and then you substitute when you calculate. So memorize this law. I can do a demonstration of this. Let's say this is body 1. Then this is body 2. You see? Let me say this is the center. This is the center of the second body. So, then, the distance between their centers is R. The distance between their centers is R. But the law, what does the law say? That force of attraction is inversely proportional to the square. So this means this distance must be squared, and this distance is in meters. I think this is in meter squared. So this distance there, okay, let me just this is distance R in meter squared. But according to the law, remember that thing will be squared. You see? So yes. Yeah. This one is attracted there, and this one is attracted there. There is a force 2 there. There is force 1 there. Looking at the arrows, this one is to this, and then this one is to this. So these forces are opposite. That means I can think of Newton's third law here. Because that force is the same, but in opposite direction. So, yes, that's the diagram I just put there. And yeah. So this is the law. Today I'm all about Newton's laws. Cram these laws. Cram these laws. I think today is all about these laws. I'm just interested on cramming these laws. Newton's first law, Newton's second law, Newton's third law, Newton's law of universal gravitation. I don't want to confuse you, but let me just tell you the facts. You see this law and Coulomb's law, I see them, they are similar. In the sense that here they talk about electrostatic force. Here they talk about force of gravity. So the formula here is K, charge 1 times charge 2 all divided by R squared. Look at the similarity here. Remember, this is Coulomb's law. I'm not confusing you. This is under electrostatics, but I'm just showing you the similarity there. So in this part here, you say here between the accents, but here just said between the square of the distance between them. Charges are very small, but the objects now, any object is big. I think because they are talking about charges, they just the square of the distance between them. All right, okay, fine. I didn't mean to confuse you, but I was interested in the similarity here. You see, these two are similar. So guys, I think for today I stop here. I hope you understood these Newton's laws. So please cram them. So the next video I'm gonna do the questions or do the examples on how to apply the answering the questions. You see, yeah. But for now, I want you to understand these laws. Okay? Yeah. I think that's it for today. Thank you for your time. Meet you on the next video. Don't forget to comment, guys. Comment on the videos. Please comment on the videos. Then hit the follow button, and then we are following each other. That's it for today. Thank you.